everyone. So today we're going to continue the conversation about polymorphism, and to do that we have an expert in polymorphism, Dr. Fernanda
Peyronel.
Thank you. I would have not come close to that. Is an expert in chocolate polymorphism, and we'll give you a little bit of a demo here, and then we'll talk about some different types of chocolate and some of the implications of structure on chocolate.
Great. Well, thank you for having me here and giving me the opportunity to bring chocolate to you. So what I'm going to show you is the attributes of good gourmet chocolate bars, and many of us know what that is. You want a nice mouthfeel. It's smooth. It doesn't have an after waxiness feeling. When you look at it, it's gloss. It snaps when you crack it, and it melts at less than 34 degrees Celsius. You might not pay attention to that, but remember your temperature, your body temperature is between 36 and 37. So the cocoa butter is the ideal fat in chocolate that will melt at this temperature that we like. And how do we achieve a good chocolate? It's by following specific protocols during the manufacturing process. So in here I'm talking about 70% dark chocolate, which means there's about 30% sugar, and between cocoa mass and cocoa butter, it completes the 70%. Vanilla beans or sometimes lecithin or PGPR are two other emulsifiers that you might encounter on a chocolate bar. So how do we achieve that? Sorry, I'm not in there. Should be there. So this slide is showing you non-temper versus conventional tempering. What is this? It's the way of manufacturing the chocolate to achieve those properties that we like. And the non-temper one, I don't know how to show. The non-temper one you can see on the y-axis. You go through a melt, you wait, and then you crystallize. It shows 50 as a maximum and 14 to 16 degrees as the lower temperature, where you bring the chocolate and you wait there in order to have the cocoa butter crystallize. A good conventional tempering protocol is when you go up high, then you bring it low, you wait a certain period of time, and then you melt again. So you're playing with the polymorphism, all those nucleation sites that are not the right ones. With chocolate, we are aiming to have a polymorph of beta 5. Another way of achieving a bad chocolate is when you don't wait enough time, or when your ramp of cooling and heating, it's either too quick or slow. So you can have an over-tempered or an under-tempered chocolate, and again, it's not something that you like in your mouth. And finally, there's another way of making good chocolate, which is the seed method. You have a good chocolate that it's already in beta 5, and what you do is you add this seed into your melt chocolate, and that's going to crystallize everything in beta 5. And of course you do that once you have cooled it, and there's some numbers to guide you. 34, it's the ideal temperature when those seeds are added. So how do we check if we have a good or a bad polymorph? It's by X-rays. And here the first two, number A, the figure number A, is showing the chocolate out of the package. You put it in the X-ray, you are looking at the wide angle X-ray scattering. The second one is after tempering. So what I did was I melt this chocolate and I went through the protocol of tempering it. And number C is the non-temper one. And non-temper was achieved by melting it and cooling it quickly. And you can notice here two peaks that either appear or disappear. The first one, close to 4.5, 4.54, and these are angstroms. We are talking about distances between atoms And it's mainly the cocoa butter, what we are looking at. You can see that in curve number C, the peak that it's at 4.54 has shifted. So that's telling us that we are not in the form beta 5. And the same with the second peak at 4.13, which appears in the non-tempered chocolate, but it's not present for those tempered ones. The second key indicator to know if we have achieved a good chocolate, it's by melting the chocolate. Once you have crystallized your chocolate bar, you melt it. If we look at this table here, Willie and Luton have given names from, in Latin names from 1 to 6. Biocat has given name from gamma, alpha, beta prime, and beta. Beckett has